Hi, this is Miss Borgen. In this video, we will be learning about particle diagrams. Make sure you have your notes pasted in your notebook as you complete this lesson. Pause the video as needed to make sure you have all the important information recorded. A particle diagram is a model that shows the behavior of particles in different states of matter, in different temperatures, and with its surroundings. This model shows specifically how particles behave at the molecular level. As a reminder of what the different states of matter are, we have solids, liquids, and gases. A solid has compact molecules. It keeps its shape. If you notice in this particle diagram, there is an order to the molecules. Even though it is a solid, the molecules are still moving slightly as indicated by the dashed lines. A liquid takes the shape of its container. The molecules are more spread out and move around more freely than solids do. Their movement is indicated by even more dashed lines. Gases fill the space that they have available to them regardless of the size or shape of the container. Their movement is extremely random and the particles are spaced out very far from each other. The movement of these particles is again indicated by more movement lines or even arrows. We have three rules of particle diagrams, the first being draw distinct, countable particles. In our previous examples of states of matter, all the particles could have been counted. The second rule is different substances have different particles. You could indicate this in two ways, have different shapes or use different colors. For example, I could indicate carbon by drawing circles and indicate nitrogen by drawing triangles. When I do this, it is important to also draw a key for the interpreter of the particle diagram to differentiate between particles. So carbon is circles and nitrogen is triangles. If I want to keep the same shape, I could just change the color. So I could draw blue particles for carbon, and I could draw green particles for nitrogen. And again, I need to update my key. The last rule is the number of particles indicates mass. If I draw 5 particles, and my key is 1 gram is equal to 1 particle, I now have 5 grams. We talked about the states of matter earlier, but how can I draw a particle diagram of me heating up a solid? You can see I have a heat source. Since the prompt says I start with a solid, I'm going to start by drawing my solid. It is important that my particles are distinct and countable, so since I'm starting with 6 particles as my solid, as I heat up I have to maintain those 6 particles. Now that I have more heat, I'm going to draw my 6 particles turning into a liquid. Their movement is random and they're going to have a little bit more movement, so I'm going to make sure that my dotted lines indicate their movement. And I have 6 of them. When I add even more heat, my liquid is going to turn into a gas, and that gas is going to fill the entire container. In order to show movement of these particles, I'm going to draw arrows. That's going to indicate that they're very random and move quickly. If you look at this example, you'll see that I have a particle diagram with countable particles. If our container shows the volume, we can actually figure out the density of our substance. My container has a volume of 10 milliliters and I have 8 particles. I can set up the density equation, which is grams over milliliters, and plug in my knowns. I have 8 grams of particles in a 10 milliliter volume. If I divide this out, I now have a density of 0.8 grams per milliliter. If you have any questions from this video, make sure to write them down and ask your teacher later.